Yo, yo, yo. What's up, everybody? Welcome back. Today we are trying to write some sequence of code that takes, goes from the bootloader on a Raspberry Pi Pico into main. No SDK. For context, I have a controller, little Xbox controller with some paddles on the back. The paddles on the back are remapped in firmware to other buttons on the controller, right? Because you're plugged into the Xbox, and you want to make sure that the Xbox knows how to interpret those paddles, right? So you map left paddle to A, right paddle to B. You now have some extra buttons that you can use your little ring fingers for. That's pretty hype. But I don't have an Xbox. I have a computer, and so I would love to be able to. How to say this? I would love to be able to have those paddles be their own independent buttons. And so we're on this adventure trying to reverse engineer the firmware on this controller, right? We haven't had any success doing this on the software side, but in hardware, we have found a EEPROM chip on the board of this thing. And we're thinking maybe if we take this thing off the PCB of the controller and we just dump it, maybe the firmware image is in there, right? And if so, then we can start reverse engineering it. Maybe not. Maybe there's some encryption keys in there so for us to decrypt the firmware package. Who fucking knows? I don't. I just want to look at it and see because it's my only lead right now. And so we have bought this guy, little Raspberry Pi Pico. He has some I2C pins on him. Can I open this image in a new tab so I can zoom in? Right? He's got little I2C pins, right? Which means that we can talk to this EEPROM controller. And we are kind of on this adventure trying to get this guy up and running with no use of their SDK because we like to make our lives hard around here. And so what we have right now is we have managed to get the world's shittiest bootloader on there, right? We have something that says, let's put this stuff in some boot2 section of a compiled ELF program. We are going to just breakpoint, and we're not going to do any bootloading, right? We're just going to put 100 in R0. We're going to add 1 forever. This is just a proof of concept to make sure that we've got the correct stuff in place for boot stage 1 to loot boot stage 2. We have to checksum this thing, make sure that it's the right size, etc., etc. We have this linker script here that kind of does what we want. So we say basically pad this, take anything in the boot 2 section, pad it with zeros so that it's 256 bytes long, make sure that that is in fact actually 256 bytes long. And then we wrote a quick little program to patch the ELF at the end with a CRC following their CRC parameters. So we have something that is running on board, right? So if we go in here and we say let's program and run this guy and look at GDB, we can see that we disassemble the current address that we're at, maybe plus 16 bytes or something. And we see we have our breakpoint, we have add, set register 0 to 100 and increment R1 and branch back. And we jump next instruction a few times. And we, maybe info registers R0 or something. We can kind of do this a few times and we can see this thing incrementing like we expect. So hell yeah, we have some code running on board completely on our own, which is pretty hype. Pretty hype. And now we have to do something interesting with that code. So that's kind of stage 2. Stage 2 is to do anything at all. So the plan of action is to try to, write some code to be run, right? So we basically have, okay. So I guess to explain this a little bit further, there's read-only memory on the flash. We can't touch this. We don't program this. But in here, they have a bootloader stage 1. This guy, he's going to look at flash, and he's going to take the first 256 bytes of flash, and he's going to copy them into RAM, SRAM. And he's going to copy them kind of into the very end of SRAM, right here. He's going to copy them to the very end. Like this, right? So the job of our bootloader is essentially to be where does the rest of the code want to live, in memory? Does he want to be executed in place in the flash? Does he want to be copied to maybe the beginning of RAM? Maybe we want to copy paste it over here. But we need to put it in the right spot for him to be able to execute, right? Because he's going to do things say, let me look at this constant. You put the word hello somewhere in your program. Where the fuck is it? Well, according to what I programmed, it's just at some address, right? And so, depending on if we expect this thing to be running from the flash directly or in SRAM, we need to put it in the right spot so that when it looks at that address, the data that it's expecting to be there is there. So that's kind of like the job of our boot stage 2. And then we have to jump into that thing and maybe run some code, right? So the goal, so that's why we have to compile some code to copy over or to run. Then we're going to copy into SRAM, I think, because that's a little bit easier. Then we got to find some way to run it. Probably we want to set up a stack and stuff so that C runtime kind of works. I don't really know what we expect in the C runtime other than just int main void probably expects that his stack pointer is in a valid spot. I don't know what else we really need, but we'll kind of see. And then maybe we run in. We'll see. Okay, chat messages. How did you get the knowledge you have about programming Linux? Just doing it a lot, man. You just find something I'm interested in, try it. You learn something, do it again. Just a one long iterative loop over 15 years. So that's, basically what you're seeing right now is us taking a hard path to get to somewhere. And by doing that, we are learning. And we'll have more tools in our tool belt for next time we do something. And you just do that forever and ever and ever. Amen. So, sorry. Church bringing up is leaking. Is there a performance penalty running it from flash in place? I'm not sure. I think I was reading in the datasheet that they might have single cycle guarantees, assuming that the execute in place cache is good. But I would assume that if you're doing random access, then how could it know? So I'm not 100% sure. I would guess that there's a slight performance penalty. Who maps ROM memory into memspace? I think that is controlled by hardware memory mapping, I think. So ROM is just at address 0. ROM contents are fixed at the time silicon is manufactured. And yeah, where is the bus fabric stuff? Right, so I think that when you do a memory read, it just hits the bus. The bus. Right, so I assume... is there a block diagram? Right, I assume that there's some chip somewhere when we write to this bus that kind of routes addresses to the correct chip, right? And so I assume, right, you can kind of see it here. Maybe it's not even a chip. Maybe it's just the way the lines are hooked up. When you write to address 0000, it just ends up at the right spot. Maybe. I'm not really sure. But yeah, I'm not sure. Do you need a DMA to move ROM to RAM? I don't know. I don't know if we can read... Well, so first of all, we don't ever read from ROM to RAM. That's kind of done for us. Someone probably does that. But if ROM is some fast to read chip or something, then maybe you don't have to, right? Maybe read-only memory is a small chunk of basically RAM that has its write lines disabled or something. So you might not need... maybe this is RAM effectively. I don't know. But we are going to be copying from flash to RAM, and I don't know how to do that yet. But first, let's get some code in the binary for us to move and figure it out from there. So can we put something that's let's make a assembly file CRT0 container runtime 0 or C runtime 0. I think this is what is usual. This is what the thing that is run before main is usually called. I'm just copying this name from places I've seen before. But let's kind of just say that we have some code, and maybe we have entry. Maybe I think it's called start usually. And can we just say that we have start here, and in start we're gonna be maybe we do the same thing here where we set a breakpoint and move something into R1 and add to R1 just to prove to ourselves that we're in a different spot than the bootloader. I guess technically the bootloader won't be doing that loop anymore. So we can just do this. We can just do this little test loop. Sure. And then our compile script, I guess we're going to, I wonder if we need to do this in stages. We might not need to. We might be able to get away with doing this all at once. Can we define a cflags variable just to kind of make our lives a little easier? Like, can we just do this in one shot? You know, I don't know. So we're like, I want to take this thing and I want to generate, we're calling it boot2.elf for now. I guess that's fine. And we want to take in boot2.s and crt0.s, I guess. Sure. What happens if we do that? He's mad because no linker script boot2.ld. Why not? What the fuck is he talking about? Yes, there is. It's right here. Oh, because he's got it in quotes like a dumbass. I see. Maybe? There we go. Okay. That builds. And so now what do we have? We should have like something here. I actually want the music back on. I just wanted to turn it down and didn't want to do it during the intro. There we go. Okay, so we have text. We have boot2. Annoyingly, boot2 is coming after text. That's bad. That's bad. So we need to make sure that boot2 is literally like the first thing. So I think we're just like, yo, can you put this in probably RAM? We're gonna like expect that this stuff executes from the context of RAM, but it's stored at flash. I think that's what we want here. And then I think we just want to say like, take everything that is in text, right? And then I think that we want to say here, I think that we want some linker symbol for text start and text end so that we know what to copy, right? And then we might want to also assert that that text start minus text end is less than 256k, right? And just say you know, like executable must be smaller than RAM. And then also this should be 256k minus 256 because we have to make sure that the bootloader is like running when we're copying stuff in, right? So we don't want to overwrite the bootloader while we're copying the rest of the program. I think. Maybe there's some clever way to make that work, but I don't know what it is. Does that make a little bit more sense? Okay. That's interesting. So he's saying, yo, this text that you created is not less than this? Really? That doesn't make any sense. What's a comment in this language? Hi, by the way, and happy Friday. Happy Friday. How do we Google this? Linker, script, comments. What the fuck? Okay, sure. I don't believe it. You know? Right? Text size is 8. So, like, what the fuck is going on? Oh, it's the other way around. Oops. Oopsies. Much better. Much better. Okay. So now we now are in the case where boot2 comes first, which is hype. And can we look at segments in here as well? So here, that's not good. These should not be going to the same physical address. I don't think. Which means that we don't understand this at mapping correctly. Because I would have thought that this goes like, okay, we put this in Flash, then we put this in Flash. Right? You can probably do size of text. That seems nicer. I don't know if you're just guessing or not, but fuck it. Yeah, that does work. Right, if we write 0 here, he's gonna crash. Yeah. Nice. Okay, so why are these going to like the exact same fucking spot? That seems bad. Right? So like, the fuck is going on? Can we look at like another linker script? Like theirs as an example? Let's look at their copy to RAM version. So they like, yeah, they just write to Flash, to Flash, to Flash, to Flash. They do just write some stuff to RAM. Which is confusing because, oh, here, like RAM at Flash, RAM at Flash. Maybe you need to align. Maybe you need to move the cursor forward. Yeah, maybe? Although that doesn't seem right to me. I assume that this is not the case. Yeah, something about this seems wrong to me. I don't understand. Linker script putting multiple segments at same physical address. This seems like a question for the idiot. We can just say like, what the fuck is going on? We'll see if he might have no ideas, but he might have some ideas. We'll see. Why, when I do read elf segments on this, does it put both text and boot2 at physical address, at the same physical address? Shouldn't it auto increment? Blah blah blah. Flash memory engine is common technique in embedded systems where programs do blah blah. But how can I say? Oh, maybe. Can we look at like another example? Let's just double check that this is not the case. Like that something that works doesn't do the same shit. So we have our like example here. Yeah, this is more what I was expecting. So it's because they kind of managed to keep that shit in the same segment, I guess. But even then, data and BSS are ending up at like incremented physical address. So how the fuck are they doing that? What am I missing? And as usual, the idiot's not helpful. um. Okay, so like, what are the sections that we saw? It's like data and BSS. So they just like huck shit in Flash, then they huck more shit in Flash. They don't say RAM at Flash, which is maybe interesting. I wonder if that's relevant. Let's try for a second just writing in the linker script. Just like stick it in Flash. Just to see. I don't think that this is correct. Text will not fit in region Flash. The fuck? That's true. This shit is big as fuck. I don't know how big, but big. Raspberry Pi. Pico, oops. Probably this is defined by this is pinout for the Pico W. We're not a Pico W. We're Pico. This is probably defined by the flash that is physically on this thing, right? Which, if I remember correctly, is over here. This thing. If I remember correctly. 16 megabit? Is that what that means? 2 megabyte. 2M. If K is allowed, is M allowed? Looks like it. Okay. So can we now look at read elf segments boot 2? Okay, so that's interesting. So now they're going to the same section. So if we write RAM at, oh, I think I might understand. Wait, why? Oh, it's we need the first arrow, right? We need this. No, oh no, even this is doing the same shit. So how come writing RAM at flash? Oh, unless this offset? Maybe it's like this. I don't understand. Because I feel like when they did it in their linker script, it worked fine. I wonder if, like, what's the difference between keep and this? We need to learn the linker script language, I guess. I wonder if this is relevant as well. Yeah, I don't understand. Yeah. Something here does not line up. Do we just need to like read how linker scripts work? Probably. Probably. Okay. Command language provides explicit control over link process, allowing complete specification of mapping between input files and output controls, blah, blah, blah. You may supply a command file to linker script through the -t option or implicitly as an ordinary file. Normally you should use this, blah, blah, blah. Okay. Collection of statements. Some are simple keywords setting a particular option. Some are used to select and group input files or name output files. And two statement types have a fundamental and pervasive impact on linking process. The most fundamental command is the sections command, which is this. Okay. Go here. And then the memory command. Sure. So can we look at this? Sections command controls exactly where input sections are placed in the output sections, their order in the output file, and to which output sections they're allocated. You may use at most one sections command in the script file, blah, blah, blah. Okay, define the entry point, assign value to symbol, describe the placement. Okay. Anything here, entry point, blah, blah. Okay, section definitions. Most frequently used statement is the section definition, which specifies the properties of an output section, its location, alignment, contents, and fill pattern, target memory region. Most of these are optional. Simplest form is this. Okay. Name is the name of the output section. Contents, go there. Sure. For example, a list of input files or sections of input files. The white space around sec name is required. Okay. Yep, makes sense. So that it's unambiguous. Other white space shown is optional. You do need the colon braces, sure. This needs to meet the constraint of your output format. Sure, I don't really give a shit. Discard can be used to discard sections, sure. And he will ignore stuff that doesn't have any contents. For example, this will only create foo if this exists, sure. Section definition, you can specify contents of an output section by listing particular input files or by listing particular input file sections, or a combination of the two. You can also place arbitrary data in the section and define symbols relative to the beginning of the section. Sure. Oh, so you could do this where you just like data's A, B, and C. You can specify one or more sections for your input files for insertion, blah, blah, blah. Oh, instead of explicitly naming particular input files, you can refer to all files from the LD command line. Use star instead of a particular file name. If you have already explicitly included some files yourself, star refers to all remaining files. Those who place in the output file have not yet been defined. For example, to copy sections 1 through 4 from an Oasis file into the text section, into 13, 14, and sections 13 and 14 of the data section. Sure. Okay, so I don't know why we're writing keep, but we'll maybe get there. Specify where in your input file put uninitialized data with this notation. Common by itself refers to all uninitialized data from input files. File name common is uninitialized data from a particular file, blah, blah, blah. Okay. Sure. So, like, you might do this. Okay. The following example reads all sections from all.o and puts them at the start of section output A, which starts at location there. Okay. Cool. That makes sense. The foregoing statements arrange in your output file data originating from your input files, blah, blah, blah. So create object symbols, create a symbol for each input file in the current section. Interesting. Okay, I don't really care about that. Byte, short, long, squad, fill. Okay, I don't really give a shit. Optional section attributes. Here we go. This is what we're looking for. So we have name. We might say start. You can force the output section to be loaded at a specific address by specifying start immediately. Sure. you can include block specification to advance the location counter prior to the beginning of the section, so the section will be placed at the beginning alignment. Sure. So you're like, I want this to be aligned by 4. Sure. No load will say, don't fucking load this shit. Sure. At. So that's here. This expression follows the at keyword, specifies the load address of this section. By default, the default, if you do not use the at keyword, is to make the load address the same as the relocation address. This feature is designed to make it easy to build a ROM image. For example, the sections definition creates 2 output sections, one called text, that starts on this, and one's called mdata, which is loaded at the end of the text section, even though its relocation address is 2000. So he puts at here after text. Okay, cool. That makes sense. I mean, they're not doing any of that shit in here. I don't think. Yeah, they're not doing that, but we'll keep that in mind. Assign the section to previously defined region memory. See memory layout, okay. P header, sure, including fill, definition specifies the initial file value for the section. I assume this is like by default 0 or something. Okay. So we have, you can also do ld -- verbose to get more info. That might be useful. Origin is a start address in physical memory. Sure. Once you have defined a region of memory, you can direct specific output sections there by appending a command in this within the sections. If the combined output directory region are too big for the region. So what I'm confused about is like the fact that this works is so confusing to me. Right here, we're like, bitch, these things are like sequential. It's as soon as we start using this at shit. Compile. Where it's like kind of weird. And also, am I crazy that this at syntax wasn't talked about here? Like they have at as an attribute somewhere else, right? Wherever the fuck that was, they have it here. Which I think kind of lines up. They say to put like mdata after text here, they use the at and they explicitly initialize that shit. Okay. Which I don't really understand why. Maybe this is like an alternate syntax for the same shit. But that doesn't explain why like their T data and data don't end up at the same spot, but our shit does. May I ask why even bother with an elf file? Once on flash, it doesn't even matter. The flashing utility reads the data from the elf file, and it helps for like debugging and stuff because the debugger knows how to read elf files as well. Ah, nice. How did you get here? This is in bin utils, hype. So output section LMA. Every section has a virtual address and a load address, hype. Virtual address is specified by the output section. At keyword takes an expression as an argument. This specifies the exact load address. Load address of the section is sent to the next free address in the region, aligned to the section's alignment. So this is what I'm fucking confused about. Right? This seems like it should work. If neither at nor at is specified, the linker will use the following heuristic. So is this the same? So at here at the beginning with specifies an exact address, and this specifies a region. I wonder. I wonder if I'm wrong here. I wonder if this offset here is an important part of this. So maybe they're saying fizz address plus offset is where this thing actually ends up. Could be. Although the physical address there would be wrong then for this guy when he's programmed. Offset is the file offset. No, yeah, that makes more sense. That makes more sense. I wonder if it's because, like, there are, like, different flags here. That's very strange. Very strange. So all of this, like, align shit here, this is about, like, virtual addresses, right? I mean, we could do, like... I just don't think that's really right. Yeah, I'm confused. Maybe the problem with the at no space is the spelling of the keyword. Oh, could be. I don't think so, but maybe. Also, now this is in the wrong fucking order? That's fucking weird. What the fuck? Okay, that's fucking crazy. Am I... Is that, like, non-deterministic? Like, am I fucking crazy? I mean, I guess it makes sense if it's not correctly identifying, but I don't understand why it's different now than it was before. I guess we wrote RAM here before. Yeah, okay. Interesting. I mean, it's clear to me that this isn't working, I just don't know how to fix it. I mean, like, at here, I think this fixes it. But I don't like it. You know, if we did, like, this plus size of boot2, I think this does the right thing. Right? Now he has the right physical address. But, like, I don't feel like I should have to do it that way. You know what I mean? Linker script at arrow assigning duplicate physical address. I don't know how else to, like... You know, nothing of this is really, like, explained to me. I feel like asking the idiot is, like, the best option, but he wasn't helpful. But we can give him more info this time. We can say, we can say both of these sections in a linker script are being assigned the same physical address, the start of flash. But if I assign them both to flash without RAM at, they behave as expected and get sequential addresses. What's going on? Maybe he'll help me. Maybe not. Tells it to linker to load this with flash memory region. Okay, this means that both are at flash memory. In the second case, you start both without this. The linkers interpret this as this immediately after boot 2 section in this scenario. Why is it different? Why is it different? Yeah, but in your example, they will be linked expect with virtual memory in flash as well. You fucking idiot. He's like, you could just do the thing that you said worked. Why can't I? Okay, this is fucking stupid, right? Like, it's just. Also, I'm not even convinced that he's right. I'm kind of curious to see it, though. Right? I don't think that this works. Okay. That's interesting. This maybe? Where did you get this? All things embedded mastering. Oh, so you just clicked on that link on Google? But you're saying, look at this guy. Okay. Linker script keeps a variable dot called the location counter. But I think the location counter is like virtual memory. I think. It's possible. Oh, here he has some examples of at flash here. This will place the SR section of the flash region. Both LMA and VMA will be the same. How about loading the section of flash, but we're saying virtual memory as just SRAM? We do this. Since they have maximum size, the linker condition error. It's possible to create new symbols. Okay. I feel like I'm not doing anything wrong. You know? But I guess it could be like. I'm curious to do like if we do this, just out of curiosity. I don't really believe that that does jack shit, but yeah, it's very strange. It feels like it's fucking bugging. Am I crazy? Or maybe the command line arguments we were passing in the other version when we built this thing are different? Maybe? GC sections, no warn RWX segments. This is like an output file. Yeah, I mean GC sections, but that yeah, it doesn't make sense. Nothing in here seems like it should adjust the behavior. What is specs? What the fuck? Override built-in specs with content file. What does it mean? Oh, that's interesting. So this could override like the linker command and stuff, I guess. No sys specs. Who fucking knows, man? Who knows? This is crazy though. I mean, do we just hack it to keep going? It's really bothering me. Because it feels like I'm not doing anything wrong. Also, it seems like this keep, based off what we read, isn't required. I'm kind of curious to know if that changed anything. I assume it doesn't, but obviously not. I wonder if it's because the virtual addresses are different. So it doesn't realize that it's going to the same spot. Yeah, it feels like this is very strange, right? So here the virtual address correctly incremented, but the physical address, he just like hasn't figured it fucking out. I assume that it's not like there's like a missing semicolon or something. It's very strange. I wonder if this is interesting as well. The fact that boot 2 has like a different flag set on it. I don't really know what that means. Can we go back here? Can I define as part of my like section statement if it's like executable or what? Like atter? This is an attribute of memory. Add gnosis.spec, it removes all defaults. Yeah, maybe that is worth. Spec gnosis spec. I thought that because it wasn't there, it just wasn't really happening. Yeah, this isn't. Oh, specs plural. Might as well. No such file or directory. Is it like in here? I don't understand like where this is coming from. Like, how come when I compile this? Oh, it's gnosis specs plural, of course. Oopsies. Oopsies. Of course. Okay, there we go. Doesn't help, but doesn't seem crazy. Didn't seem like a crazy thing to try. Everything you ever wanted to know about linker script. MC Young blog has a really good linker script article. Gadget T saying at region at LMA region, but like that's. Am I crazy that like why is this at LMA region just not incrementing the fucking address? I feel like I'm losing my fucking mind. Right? He's going like, we're going like, put this thing in boot 2 RAM, and we're gonna store that shit at flash. And we're like, put text in RAM, store that shit at flash. And like, why the fuck? Why the fuck? Are they like, fuck it. We do put them both at flash, but the very fucking beginning, it hasn't figured it out that they're. Region is the memory region defined, LMA region is the loaders. I understand that, I think. Right? So my understanding, which could be wrong, is that I'm saying, yo, I got like virtual memory here, like where the thing is going to be in terms of how it's going to be linked in the program. So like when I try to like branch to some label, that's going to be in RAM or boot to RAM, depending on like which of these guys I'm looking at, right? But we're actually going to put the data of this stuff in Flash, right? That's my understanding of these. And that if I put boot2 in Flash, then I put text in Flash, they should go back to back. That's my understanding. And it just seems to not be doing that. So in both sections, you're saying that load address is Flash. I want yeah, I think so. And I want it to like auto increment, because that's how the programmer knows where to put this stuff, right? So the programmer, he's gonna look at each of these segments, and he's gonna be like, let me put it at this physical address. I guess we like the only info that we have here is like their linker script works the way I would expect it to. And so we should try to bisect kind of the difference between theirs and ours, I guess. So if we were just like, let me think. I guess they're like putting stuff in Flash directly in between, which might help. I wonder if it's like, if we sent this guy directly to Flash without the trickies. Okay, that's a clue. That's a good clue. So we're seeing two interesting things here. One is that the address of these guys are getting like really fucking far apart. Two is that this physical address mapping is working as expected. Okay. Now, like, what is the difference? I feel like it's got to be a bug. Right? If we're like, what do they say? You can do something like this? I feel like it feels like, what's the output of verbose? That's a good idea. WL verbose, probably. Okay. He's like, I'm using this script, and otherwise he's not really saying anything too interesting. Not saying anything too interesting. Yeah, I feel like it's, I guess saying compiler bug is like noob shit. Like it could be, but blaming them like directly seems kind of silly. But I just don't have another good answer. And it feels like this is the right thing to do, right? Because if in boot2 we try to branch with any like non-relative instructions, it needs to know where it lives. But maybe they just kind of get away without doing that. Like the fact that this works, this is probably like fine. This is very strange to me. I wonder if like the program sections need to be like a certain size. if we were like align something like this, I wonder if that changes anything. I wonder also if like the fact that this is going to like a completely different initial section like resets something. So like in their shit, they're like send this shit to RAM, send this shit to Flash, send this shit to RAM at Flash, back to back. Curious about this keep keyword. What are we trying to achieve? I haven't seen the first 30 minutes. Yeah, okay. So all we're trying to do is get data layout that says in the elf file, put link boot2 segment such that all like virtual memory address, like all use, I guess, of like of addresses in the program are in a way where we expect boot2 to be at this location, right? So I say branch to this label that uses an absolute address or something. We want to make sure that that absolute address knows that it's loaded at this location, right? And then we're saying store that shit in Flash, right? Because we need to make sure that the programmer who reads the elf and uploads him knows that this is supposed to be stored on Flash. Then we're trying to say text section be stored on Flash after boot2. That's what I want. As far as I know, the sections have to be in virtual memory order. Oh, that's interesting. That's an interesting thought. Ah. Ah, that's interesting. Of course. Of course. And so that's why you would do this way, because Flash comes before RAM. That's a little annoying, huh? I guess we can put boot2 at the end and just say this shit starts at like Flash or something. Is this allowed? Like we could do this. Um Yeah. Okay. So this goes at the bottom. This kind of solves the problem. It's kind of fucking weird, but you saying it that way does kind of make sense. Yeah. Sure. Sure. So because of the fact that the virtual addresses were out of order, it might have got a little angry. I could see that being something. You might want to review what happens when no at is included. If the section has a specific VMA address, then this is used as the LMA address as well. If the section is not allocatable, then its LMA is set to its VMA. Otherwise, if memory region can be found, is compatible with the current section, then this region contains at least one section, so the LMA is set the difference between VMA and LMA is the same as the difference between the VMA and LMA of the last section. Ah. So maybe it's this. So like there is no offset between the last two segments, so it doesn't create a like gap in physical memory. That's possible. Um Sure. That seems reasonable. Okay. At address of text plus size of text. Yeah. So we could do it that way too. Where we could go like, this shit goes to Flash. And so we're basically saying like, hey, this guy can't fucking implicitly figure this shit out because of the fact that there's no gap in virtual memory addresses. So we're like, here we're like, just go like at adder boot2 plus size of boot2. Oh, this gives me the wrong address though. I want like is there like a, I guess it's, I wonder if you can do like this. No. He doesn't like that. Because you can't have two at statements probably or something. Why does that work? But like size of, can we do 0 plus size of boot2 or something? No. Can we get rid of this fucking verbose flag in the compile script? This shit's fucking annoying. Bad value. Okay. I see. Okay, it's fine. I'm just not gonna think about it too much. I think it makes sense. The argument that these things have to be in order and like the virtual memory gaps makes it like matter. This just feels like a more sane way to do it, where we just specifically specify boot to flash as its own region, and then everything else will just work, I think. This is fine. Can we now see if we can program this thing and it still works? Good. Seems like it does, which is good. It seems like we didn't break anything too heavily. And I guess we should actually fucking try to read the stuff in Flash. I'm curious about this. I can never understand why people like you don't make startups. People with 10th of your experience level makes it frustrating me that smart people don't. I mean, I have zero fucking interest in making money. Why like making a startup sounds stressful as fuck. And also, what would I make? I don't have like a problem I want to solve. Programming ability has nothing to do with your ability to make a good business, right? You would have to like it's just a completely different skill set, even, right? It's like identifying what people need and then building it is just so different than being able to build stuff. I know what I'm interested in, and the things that I'm interested in don't make money. And I have no interest in like being a salesperson and selling stuff. It's like I just do not care, and I can't. I'm really bad. I'm extremely bad at doing stuff I don't want to do. My friends were arguing about this, or my friends were calling me stupid at a bar recently because I was claiming I don't do things I don't want to do, and they were claiming that I'm just wrong about my definition of want to do. But like, I don't know. If I don't want to do dishes, I'm really bad at, I have dishes that I haven't done, like some, not all, but like some dishes that I haven't done for like a year. They're just sitting in the same spot on the counter, and I look at them and I go, gotta fucking clean those. And I look at them like, I don't fucking want to. And so I can't make myself do it. I just can't fucking do it. I'm really bad at making myself do stuff I want to do. And I just trick myself into like the things, just to be clear, I'm not using year-old dirty dishes. there's just a couple plates that I'm just like, I don't need them right now, and I don't want to clean them. And it's just, I can't. We're never beating the stinky allegations after hearing that. Dude, it's like breadcrumbs don't get that stinky. It's fine. But it's just like, I don't know. I'm not, I can't, I'm very bad at like doing things that I don't want to. And running a business is like definitely not on the list of things I want to do. I just want to make stuff. And I like making stuff, and so I'm going to do that. Can't you just make stuff that you think would be useful, solve your problem, and host it? But like, why? For what? For like more stress? Like the end all be all of life isn't making a business to make money. I don't give a fuck. Like, I need enough money to survive, sure, and working at a company is just like a way better way to get that money. Because I don't need that much, right? So like, why just make my life worse? Take on risk, take on stress, probably sink a bunch of money into something that probably won't work, and then like spend a bunch of time doing stuff that I don't want to do to push this product. Like, I just don't care. Why? What's the point? Like, and like this idea that like you should like that you should be doing that, I think is like a value system that I just don't understand. Right? You're like, I wish you made a business. Why? Why do you care? It doesn't fucking matter. Like, businesses, yeah, I just who cares? I just can't understand it. But that it is what it is. Okay. So we should be able to start loading stuff from Flash now. We should. We need to figure out how to read from Flash. That's pretty important. I remember their bootloader stuff talking about having some built-in Flash reading commands. Where are those? Here, bootrom contents. So they have like built-in functions for some common shit that people might do that are optimized for this hardware. Memset, memcall here, Flash stuff. So they have exit XIP mode. They have erase Flash, program Flash, and flush cache, and enter XIP mode. Okay, so they have nothing for reading from Flash, except for maybe by entering XIP. This is a very slow XIP configuration, but very widely supported. Debugger calls this function after programming a Flash erase operation so that the freshly programmed code is visible to the debug host. Okay, so maybe our not very intelligent way of doing this would be enter XIP mode, do a mem copy into SRAM, and then exit XIP mode. Right? This seems like probably the easiest way to get what we want, unless it's easy to read chunks of memory from Flash directly without XIP enabled. I think the XIP copy is what I saw Mlug do in his version, but I'm curious to see, can we just fucking talk to the Flash device? I'm curious. I guess in like we were looking at like XIP controller probably. Okay, so we have like this XIP thing. Okay, Flash. Here we go. So Flash can be accessed via the SPI interface using the XIP hardware. Blah blah blah. Once configured by the bootrom and Flash second stage, XIP hardware is largely transparent and software can treat Flash as large read-only memory. However, it does provide a number of additional features to serve demanding software use cases. So what if I'm just like, copy some shit, dude? So they got like a cache flushing and maintenance, blah blah blah. What if I just want like fucking DMA copy from that shit? This is provided by the SSI interface. What is SSI? That's not SPI, which is where the thing is connected. What is SSI? Synchronous Serial Interface Controller. Okay, interesting. SSI can also be used as standard FIFO-based SPI master with DMA support. This mode is used by the bootrom to extract second stage loader from external flash. Wait, yeah, this is kind of what I'm thinking. Hi, how are you? Have stream on mute, won't hear your answer. Okay, weird. Why fucking ask? I guess this is kind of what I want, huh? Flash streaming and auxiliary bus slave. Flash is generally much larger than SRAM, blah blah. It's often useful to stream chunks of data from memory into flash. It's convenient to have the data stream this in the background. Okay, but I want to go like the other way. So you can set stream adder and stream control, probably, registers to program a linear sequence of flash reads, which the XIP subsystem will perform in the background in best. Okay, so this is kind of what I want, I think. I just want to be like, yo, bitch, DMA copy some shit to RAM, please. Seems pretty reasonable. Stream data is pushed to a small FIFO which generates direct signals telling the DMA to collect stream data. As the DMA does not initiate a read until after the data has been read from flash, the DMA is not stalled when accessing the data. Sure. Although this scheme ensures that data is ready in the stream of FIFO once direct is asserted, the DMA can still be stalled if the master is currently stalled in the XIP slave. This is solved by auxiliary bus slave, sure. So how the fuck do I do that? I guess I say stream adder stream control. So the address of the next word to be streamed from flash to the streaming FIFO. Read a non-zero value to start a streaming read. This will then process in the background using flash idle cycles to transfer a linear block of data flash to the streaming FIFO. Decrements automatically one at a time as the stream progresses and halts to reaching 0. Read 0 to halt an in-place stream. So is this byte by byte? Do I write the number of bytes I want? And then do I have to manually control the DMA copy myself? Or does it kind of figure that shit out all on its own? Yeah, interesting. Interesting. Okay. These registers are performed a linear sequence of flash reads. Okay. Hold on. It's convenient to have the DMA stream this data in the background. Yep. Do they have like a code example here? So here they're like, so you have to configure DMA to do the copy for you, which kind of sucks. That's probably more work than just enabling XIP mode, which is just like set the stuff up as an address and do the memcopy. Yeah, I think that's easier. And they said in the bootrom, the like bootrom setup XIP mode is like slow, but we don't really give a fuck if we're doing this one time on boot. Sure, let's do that. Let's see if we can figure out how to read these bootrom functions. So they say like there are things sitting in read-only memory that they've pre-programmed as like optimized functions of things. So things that, you know, are probably going to be used in most programs, or things that might be faster for them to do, knowing low-level info about the code, about the chip they're running on or something. So how do we like extract these guys? ROM function lookup. This is this is a really cool function. Thanks for showing us this, guys. This is really cool. ROM func lookup code, return ROM func lookup inline code. Okay, but like, what am I supposed to do? So bootrom contains a number of public functions that are needed in the app, blah, 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 highly optimized. These functions are normally made available by the SDK, but we're not using that shit. Assuming 3 bytes starting at address this are this, what the fuck are we talking about? Then 3 half words starting at 0x, what the fuck are we talking about? These values can be used to dynamically locate other functions or data in the boot log. ROM. The version byte offset this is informational. Bro, what the fuck are we talking about? Where is this ROM func lookup inline defined? Here. So he takes some code. From bootrom func table offset. And then returns ROM table lookup, which is ROM. Oh, I see. So ROM table lookup is a function. So this. So we call this function with some arguments of a code. Okay, which are a uint32. So how do you convert these like this to a uint32? What do these codes mean? Assuming 3 bytes starting at address 10 are this. Oh, sure. So they're like, did you read the magic from this guy correctly? Is he behaving the way you want? Then the 3 half words starting at 14 are valid. So there's a function table and then a table lookup. I assume table lookup returns us the pointer into this function table or something. Okay, so I see. So ROM table code is this. So let's start there. Let's start there. So how the fuck, what is like the expectation on calling convention here? Right, they're expecting us to pass arguments into this function. But like ARM v6 calling convention. Like where are the arguments coming in? They must be coming in probably registers or on the stack. Maybe is calling convention in here? No? Like why are they giving me C code? What is it like? We can look at like R0, 1, 2, 3, then stack or something like that. Like that's what would be my guess, but like we don't know. GCC ARM calling convention maybe? Like we're compiling with GCC, that's expected. 32-bit ARM. Architectures. 32-bit of x86 uses with many different calling conventions. Yeah, true. Okay, so that's good that they're saying that. Standard 30-bit ARM calling convention allocates 16 general purpose registers as program counter, link register, stack pointer, interprocedurals, call scratch register, local variables. Okay. If the value to be returned is too large to fit in this, or whose size cannot be determined statically in compiler time, the caller must allocate space that you want to add runtime and pass that space into R0. Sure. Subroutines must preserve the contents of R4 to 11 and the stack pointer, perhaps saving the stack with a typical function prologue, then using them as scratch space, then restoring them from the stack. In particular, subroutines that call other subroutines must save their return address in the link register. Sure, that makes sense. So the calling convention that causes a typical ARM subroutine to push R4 to 11 to the stack, then push the return address in R14 to the stack. This will be done with a single stum instruction. Copy any passed arguments to the local scratch registers. Allocate other local variables. Sure. Do call calculations and call subroutines. Assuming R0 to 3, 12, and 14 will not be preserved. Put the result in R0. What is 12? Scratch register. 14 will also not be preserved. Sure, because that's the link register. That's like the... Yep, makes sense. Put the result in R0. Okay, so we can probably assume that they're like ROM table code. We call this with R0, R1, and then the return value is in R0? We can probably assume that. Okay. So can we do like define? Is this how you do like define in ASM script, in ASM, in like new assembly? Is that like a thing I'm allowed to do? Maybe. We'll call this like lookup, like I don't know, rom func. Okay, let's just look at like rom table lookup adder, and this should be this. And then we're like, how do I like branch with, okay, branch with link register stuff? I think I saw like somewhere they were talking about like what the fucking typical ARM, here we go. ARM instructions. So is one of these like branch with link register? Here, branches. Branch with link and exchange. Branch exchange. What do these mean? Branch exchange ARM. Okay. Here, this guy tells us. Branch exchange and branch link exchange. Same as this. Great, that's helpful. Maybe the idiot? What does BX and BLX mean in ARM? What's the difference? I assume, like, this guy is going to set the link register, probably. I don't know what this guy is. He's going to perform an uncontrolled branch, jump to the target. Oh, the X is we might change instruction sets. I see. So branch B, so we might be going from thumb mode to not thumb mode. And then here, L is like, also fucking set the return address, please, bitch. And then what's like the return function? Can we look at like, you know, they must do something in here. They must have functions, right? Or maybe CRT0 here. Okay. So they do branch exchange for return? Yeah, branch exchange to the link register for return, and then probably BLX to like do a function call. Right. That makes sense. That makes sense. Okay. So we're going to be like ROM table lookup. He's like, I guess this stuff has to go below. So this is going to be like return. We're going to be like, which we might not need to do. No, we do. Okay, so he's going to be like, I guess if we know that we were called by here, then we don't need to do the exchange because we know that we're in the same instruction set. Do we have an option for branch with the link register? Do we just have like BL with link? Yeah. Okay. So in here, we can do like branch link to, you know, I guess we need to put this in some scratch register or something. So here we're like, we could be like, move R4 to the value of ROM table lookup, then branch with link register to this thing, then we branch back at the end, and here we're like, move, 10 into the value of R0. Let's just see if this does what we expect it to do. I think this should be like a function call internally. I think, right? So oops, we forgot to do BLR4 here, right? So we're like, put the address of this guy in here, call that motherfucker, and then go back and do it again. And then we should be able to see this happening. We should see a 10 in R0. So maybe before we do this, we'll put the number 0 in here so that we can like see this shit happening. That seems reasonable. Is it like this? How do I like load the address of some label? ASM arm ASM branch to label. I guess we could look at their. We had CRT0 open a second ago. Oh, so they load register with the equals. My bad. My bad. So we're like, yo, put the address of ROM table lookup in R4, then branch there, then go back. That seems kind of reasonable. Undefined reference to LR. Undefined reference to R4. There we go. Oh, so branch with link is to label. Oh, interesting. Not to register. So we could have just done like directly ROM table lookup like this. Ah, that's kind of hype. That's kind of hype. Okay. So here, we're like, let's look at what we have here. So this is the function. This is the function that puts R0 to 10. So we end up, we're here. Then we jump down to that function. No. He goes here. Why? What the fuck? Okay. So here we say list or info registers R0. At this point, it should be 0 because we just moved in there. We go next, and it's 10. So next instruction is not following branches? He just like ran this fucking function like it was no big dealio? Oh, maybe it's SI is what I'm supposed to be doing? Ah, yeah, there we go. Oh, and he knows the name. Wait, that's kind of hype. Wait. What the fuck is going on? Why does he think I'm here? Okay, we'll ignore that. List is not doing what we want it to. But this is kind of working. Okay, that makes sense. We go boot to, we jump to ROM table lookup. We've successfully called a function. We've successfully called a function. So now we want to actually call their shit, right? Instead of just putting the number 10 in there, we want to look at whatever they have in their boot ROM. And we want to pass in this code here. So if we're looking for maybe like mem copy, we should punch in an M and a C, right? So we go like move R0 the character C. So this is like mem copy, right? We like throw a C in there. And then can we do like M shifted left by 8? Is that legal? Then we like OR in a C, probably? Or maybe we can even just do this. I wonder like how fancy you can get with these like expressions in assembly land. Immediate expression requires this. Immediate 19779 is out of range. So I'm curious. Is that right? Word. I think it's like this. 19. Okay, that's good. That's good. So it looks like in our assembler we can get pretty clever with these constants. I wonder if you can even define like a macro. You could do like function has another name now. True. So we could do like code, like or like a ROM table code AB, and return this as M or A should left by 8 or B or something. Can we do like ROM table code M C? Is that cool? That's kind of sick. And then can I even like maybe I put like the fucking pound sign here? Type. Okay, so move no good. Move. 8-bit immediate. Oh, can I only do 8-bit immediates? Oh, interesting. So if I want to do a 32-bit immediate, I have to like do a shift and OR myself? That's crazy. ARM load 32-bit immediate. Sure. Oh, okay. I like that. Let the assembler figure it out? Fuck yeah, dude. Let's do that. So we're just like, yo, slap, here's like a fucking raw value. You figure that shit out, baby. True. Mem copy. Okay. That's kind of hype. That's kind of sick. So we run this shit. We go into our mem copy function. And we have like heat loads register from program counter +4. Oh, so they just like fucking like slap that shit directly in line or something? Interesting. Interesting. Disassemble. Where does it start? Here, I think. So OA. What is happening here? Oh, it's down here. Oh, I see. So they've like inlined data. They've inlined data here. So this move S, this looks like disassembly, but it's not. So these 4 bytes are like, yeah, I see. Can we like, neat. Neat. ARM loves to interleave data encode. That's crazy. That's wild. I would never have expected that they did it that way. But that's very cool. That's very cool. So your disassembly is gonna look so fucking whack. But neat. Neat. Okay. So we've like now found we can like put this thing in here, and now should be able to call the lookup function, right? So it should be able to be like BLX to R0. No, wrong. We want to do like, we need to put the address of the ROM table lookup address here. So we're gonna like move this with ROM table lookup adder, and then we call R4 with R4. And we don't give a fuck if that shit gets destroyed, right? So we don't have to back anything up. R0, we're supposed to just nuke, so we don't give a shit. And then after we call this, R0 should have the value of memcopy in here, and then we should send it back here, and we should see the value of memcopy here. I think that's right. Okay. Info registers. So that's not good. R0 still has this thing. Okay. Oh, did we not call? Did I forget to compile? Ah. There we go. My bad. My bad. Okay, so we go memcopy. We're here. We're about to jump to address 24. So here we should see it go boom. We're in like some random shit. We're stepping by instruction for a little bit. And he's fucking stuck. I wonder if it's not okay for us to be in the debugger at that point. So let's do step instruction, next instruction. Okay, that's not looking good. So what if we just don't, what if we like set a breakpoint at line 14 here instead of going instruction by instruction? Right, so if we're like breakpoint at this address, continue. So we just never get there. You're calling memcopy ran, right? I don't think so. I think I'm calling where is memcopy. I think that's what I'm calling. I could be wrong here. I thought I was saying ROM table lookup. I thought this guy returned me the value of the pointer to memcopy. That's what I thought. But I could be wrong. ROM table lookup. This is just like not anywhere. 16-bit pointer. That's fine. 16-bit pointer is confusing. Are functions not 32-bit? Oh, but I guess that all of the, since they know the boot ROM is at address 0, then you don't need the full 32 bits. Sure. I do have this backwards. It's C2, C1. So that could be a problem here. BA. Or we could just be passing in an invalid code or something. No, we're still getting stuck in whatever the fuck is over here. Okay. I think you need to read 16 bits and then cast to a 32-bit function pointer. Yeah, but I mean, we're loading them to a register, so it should be fine because the top bits should be cleared by automatically. Then I think. The stuff we saw on the register seemed kind of reasonable. I need like a fucking example. I think Mug had this in his. Let's see what he did. Let's see what he did. Bump, 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 bump. Oh, maybe he didn't do this. Maybe he didn't use any of the built-in bootrom functions. Oh, here we go. Here. So gets a pointer, so he moves R2. To 018. Oh! Right, we're jumping to 18, not reading the pointer from... I'm a dumbass. We're like, yo, put 18 in here and then jump there. And that's not right. We're supposed to be saying, look at the value that's in 18 from this guy. Then jump there. That makes more sense. Invalid offset, value too big at 18. Okay, let's look at the fucking ARM instruction reference. LDR. LDRH. Okay. Can we load... I don't know if I understand. So here I'm like, give me a fucking immediate value. Or load from... Oh. Yeah, so here we're like, take an immediate value and slap that into... Yeah, load a half word into R4 from this immediate address. Why doesn't it like that? Value too big. Am I fucking high? Oh, move. We could like put 18 in there and then load a half word from R4 into R4. Oh, he put square brackets around this thing, which it's okay with. What do the square brackets mean? They do say put square brackets here, but like, what does it mean? ARM square brackets. I think this means like dereference some shit, right? Ah. I see. So this is like, give me an offset from some address in a register. I see. So we're like, put this address in here, then load from that address here. And could we have done like equals here? No, because equals is like an immediate value. So this is like load register, give me the address of where you put the value here. But here we're like, I want to read from some address directly, which I think means you have to do it in 2 stages, maybe? Put the address in, then load from it? Maybe? I don't fucking know, man. Okay, so use a memcopy. We're about to do this shit, so we go step, and then jump to the memcopy, which is at 0x1, which is look up the memcopy code. Look up the memcopy address. It should be. But then he jumped there, which is kind of interesting. Yeah, that's not working the way I expected. Yeah, he's getting stuck there again. So let's double check what we did here. So we think that we're like, let's breakpoint here and see what we have in R4. So we need to go to here, 2 instructions. Info register is R4. So this gave us the value of x1d. So something did happen right before we had, right here we load 24, then we're like, read that shit. And then we now have 1d as the potential address of memcopy. Oh, sure. And then we're trying to call it, but with undefined arguments. Okay, right. So if we wanted to do a memcopy, we'd be like, hit me with the source and the destination. Yeah. I forgot we're calling it, like a dumbass. So where's my bootrom section that says memcopy? Okay. Maybe we should call memset instead. I think that's a better, initial test here just to make sure that it's working. So we're going to call ms here. And then I guess we'll make a function that's like lookup and call. I guess this is kind of a macro, huh? We kind of want like define lookup and call. And this is like this shit, right? Yeah. I think this feels pretty good. So now we can be like lookup and call ms. That feels kind of nice. Right? And so now we just set the values to memcopy here. Or memset, my bad. So we're like memset with destination, character, and number of times. So can we say define sram start? Where's sram start? SRAM base, I guess, is what it's called here. This. Okay, we're starting to understand. Slowly, very slowly. Oh, this is gonna get mad because this is all gonna end up on one line. We need. Does this work? Probably not. GNU ASM multi-line macro. Like, is this allowed? Oh, macro here. Maybe this is what I want. Maybe this is what I want. Macro, lookup, and call. With end macro. And then we want like args. So we want like A, B, register. And then they want us to put backslashes in front of the names. I wonder if this will work. This seems like it might not. But we'll see. So then how do I call it? Then we should, like, can we just go, like, look up and call with MS R4 or something? I don't know how any of this fucking shit works. ASM macro. Give me a better example. Ah. A equals, B equals, register equals. Okay, let's try that. We solve line continuations and miss some escape sequences. True. True, true, true. Okay. He's like backwards ref. Can we do B shift left by 8 or A? Does that work? No. He's mad. He's mad. Okay, fuck this shit. Fuck this shit. We're just not gonna macro this for now. We should let's start simple. Start simple. So we do still want SRAM base. We're getting ahead of ourselves. Okay, SRAM base. Boom. So we set this to SRAM base. We say we want to set this to 1, and we want to set maybe 10 of them. Right? Easy. We fucking call memset, and we go again. Maybe we breakpoint here. They do want immediate prefixes. True. Okay. So, not working. Shit. Monitor, reset, init. Okay. R0 gets overwritten in your memset call. True. It goes like this. Push. And pop. I wonder if my stack pointer is sane here. Or I guess we can just like back it up. We could be like move R5, R0, move R0, R5 or something. Okay, so we end up in our memset call. And we want to go to 1A. Info registers. So we're about to fucking call this shit. And we're going to this with number 1 10 times. Hell yeah. Okay. Link register also gets clobbered, I guess. Yeah, because the link register, we need to back this up before calling. So here we want to be like, so I guess we just use like, something like this. Push it and pop it. He doesn't like that. Why doesn't he like that? Pop LR. Oh. How do I pop the link register then? Pop and return, I guess? I guess is what they want. Okay. So we go into memset. This guy goes into some unknown address. He runs for a bit. He should eventually return back to memset. Eventually. Let's just fold this a little bit. Maybe hit continue. Okay, that's good. And then can we look at the content? So let's, okay, disassemble. Okay, so we jump to memset. We run our memset until we're back to boot. And then can we print the stuff at SRAM base? We should have written, you know, like 10 ones here. Which is not looking like what happened. The function returned though, which is interesting. Okay. Yeah, that's not good. So the memset call does not look like it worked. Hand wavy. But then, like, what is it doing? Can we look? So we end up like here. What's at this shit? So we're like move 0 into R3. Compare R2, R3. Walls not equal, go to 2C. Or I guess maybe branch if these are equal. R2 and R3. Sure. R3 they set to 0. Then they loaded the address at 0 into R3 or into R2, and then they compare R2 and R3. Is memset? Did I misread the function arguments here? So our understanding is that R0 here, they have loaded the pointer value into R2. So this is 0, 1, 2. That's confusing. Then does the rest of this seem like they're doing a fucking memset? Add S. No. I don't see any, like, stores in any of this. Right? So this feels wrong? Hand wavy? I wonder if this is the entry in the... Oh, wait, hold on. We might be missing a step here. So here it might be. We have pointer to a helper function, ROM table lookup. Like, what is func table for? You know? This might be an index into the function table. You know what I mean? It could be. Could be. We could double check with what Mug did. So he's like, get the pointer to the table. So yeah, we forgot to fucking... So here he gets the function pointer. What is R0 for here? The table itself. So he's got R0 as the table. Oh, so the ROM table lookup function takes the table as well. Maybe. We missed that because this doesn't fucking say what it does. But that would make sense. That would make sense. So here we're supposed to be like, this should be an R1. R0 should be the table. Okay. So here we're like here we're like put first argument, this is the table itself. Second argument is the code that we're looking up. Then all we want to do is actually fucking call the function to look up. Are we not calling that function? Oh, here. We should be branching to all R4 here. So that's this. God, this is so confusing. So let's move this up here. So we back up our link register. Back up our link register. Maybe we back up R0 as well. Fuck it. Then we call we call ROM table lookup, which is in R4. Yeah, I think I'm high. So this is call ROM table lookup, which will return the address in R0, which means that we should be able to move R0 into R4. This is like move returned address into R4. This is like restore, input R0. This makes way more fucking sense. I think. This is like ROM table lookup. This is table arg1 table arg2 code, right? Then we call ROM table lookup. R0 has address. Move the address into R4. Restore input R0. Branch to R4 again. Then we go back. That makes more sense, I think. This is fucking hard. But let's go step by step here and see if that makes sense. Okay. So here we're like, let's breakpoint, let's go to 1C. Okay. So now we are at this branch where we should be going to after this instruction, R0 should have the address of memset, I think. And so here we should be saying, here is the table, which is at 0x14. And the code for memset is this. Cool. So we go over this. He's probably looping over all table entries or something. Can we... Okay, let's do this. This is too hard. Breakpoint here. after we fucking get the ROM table address, I want to look at it. Okay. So now we should have R0. Fuck. That's not good. He's just got the value 0 in there, which seems unlikely. Unlikely to be the address of memset, huh? Let's look at what the SDK does when they call ROM table lookup. I want to make sure that we have the right fucking function signature. Okay. Yes, they call data table code. Where this is, 16? Oh, so they call the data table, not the lookup? What the fuck? So they just don't use the thing at 14. God damn it. Okay. Hold on. So, this is the data table. Okay, let's try that. Info registers R0. Still nothing. That's not good. God damn it. Everything's so fucking hard, dude. Okay, can we breakpoint here? Breakpoint once before. What the fuck are we doing here? Okay, so we are right before the function call. I can't look at the word SRAM because in Polish it literally means I'm shitting. It's pretty funny. So we are here. We have loaded R0 with the value of hex 16, which should be 22. And 1 should be the code for memset, which should be S shifted left by 8 ORed with M. Okay? Info registers. So 21325, which is S shifted left by 8 or M. 21325. Okay, so we have the data table, 16, and the address of and the code for memset. And so then in R4, we have what should be the address of the ROM table lookup, which could be wrong. This feels kind of bad. 1D here seems sketchy. Okay. But then he does eventually return. Okay, and now we have all of these guys zeroed out, which is interesting. And I assumed that the return value was supposed to be an R0. That's kind of what it felt like. But I don't really know the calling convention that well. So we're probably doing something wrong. I don't know, like, if we did the part of loading the address correctly. Pointer to a helper function, ROM table lookup. So let's just like quadruple check that we got that right. So we're like, here is at 0x18, there is a function pointer, right? So then we loaded the function pointer at 0x18 into R4. So I guess the only way to be sure here is if we look at the value here, which is that, right? So it seems like 1D is the right place to go. So I don't really understand what's wrong here, to be honest. I feel like this feels right. but the value that we got back is null, right? We get an R0 of 0. So clearly not. So either we're wrong about the calling convention, or it's not, we're calling the wrong shit. So I'm confident about the values in R0 and R1, I think, right? Because here, that's literally all they're doing here, right? When they're doing ROM data lookup, oh, this is ROM data lookup. Hold on. Is this one, this ROM data lookup is wrong. It's ROM func lookup that we want. And there he passes 14. Ah, wait. Okay. Hold on. So we put 14 here. Call this func table. Maybe we're dumbasses. Continue. Okay, not good. So this is right after. Okay, wait, hold on. Compile, run, continue. We are about to fucking call ROM table lookup with. Okay, let's see. Info registers. So now we're like, use the function pointer table. Yep. Which looks like he has the right value. And look up memset. Cool. Right? So this guy calls table lookup is at 18. H word as pointer. Hold on. H word as pointer. So he's like 18. Yeah, there's a D reference in here. Okay. And then he's function calling there. Which seems pretty damn close to what I want, huh? Seems pretty damn close. And then we go again. We have just finished this function call. And here we have 0 return. I guess 0 could technically be the no. This is the initial boot stack pointer. So the fact that it's 0 is like a really bad sign. Is it possible that like we've got the code wrong? It says that we should take the second character, shift it left by 8, and then OR in character 1. God damn it, dude. What's Mullig's thing do again? Let's compare. So he's like, whoa. Okay, so he's like, he's using R2. We're using R4. Probably shouldn't matter. He's like, put R0 as the function. Oh, we missed the step. It's not that the function table is not at 14. 14 is a pointer to the table. God fucking damn it. Everything is so hard. Okay. Info registers. Okay, so now the function table is at 0x7a. Maybe that's a much more reasonable value. Info registers. We've just called this thing. We have a fucking function pointer, baby. Let's fucking go. Okay. So now we then put the thing in R0 into R4, pop our R0 back. So the next interesting part here is at 28. Okay. So now we have the address that we're trying to write to. I guess we have to restore R1, R2, and R3 as well, huh? restore memset arguments. Okay. See, disassemble. We're trying to go to here. This is the interesting part at 28. Okay. So now we should have our initial memset arguments. We're saying give us fucking set the stuff at address 2 hex, SRAM base, set it to 1 10 times. And then R4 should be the address of the memset function, which we are about to call here. Okay. Continue. Okay, so we made it. And can we look now, print the thing at SRAM base? Oh, those are some ones, baby! Okay, uint 8t here. Car, maybe? And then can we put this 10 times? Those are 10 fucking ones. 20 times? Other shit. Let's fucking go! That's pretty hype. That's pretty hype. I guess I'm kind of concerned that we might be clobbering our own stack. Right? What the fuck is our stack pointer at? It's big number. So it looks like 2004. That's an interesting number for this. I think that this is actually very close to where the bootrom is loading. So I guess bootrom, it's probably like SRAM is like boot 2, then stack, then like we're loading over here. Load CRT0. I think it's like this. I think. We can double check this. Right, because we're like basically at 2004 1F, and the stack pointer is at 2004 1E, and probably if we print the address of 0, this is what it said the initial stack pointer was. Yeah, so the initial stack pointer was like the very fucking beginning of bootrom, and then it goes down from there. Hype. We're actually like getting kind of close. Is it time to call main? It looks like we've actually spent like 2.5 hours just trying to call anything. So we're actually pretty fucking far. Okay, but now we have like the skeleton of how to call a function that is in the... This is like a skeleton of how to call a function that is in bootrom 0. So it would be interesting to try to macro this stuff. Because I'm going to fuck this up. This is too hard. So let's just start with like a simple macro. Like if we were to say like look up function, and we are going to take in GNU ASM macros. So here they put quotes around the usage of this thing, it looks like. So if we're like A, B, right? So these are like the code of the function we're trying to look up. It should be like A, B should look by A or A, right? So this is like something that we should be able to do if we go like move R1 is equal to this. I think that's something that we should be able to do. Load register R1. Then how do I call this? Do we call like lookup function A equals M, B equals S? Bad instruction, lookup function. Is it with a comma? How do I fucking call GNU AS macro? Am I fucking stupid? This is just the same fucking thing. How the fuck do I use this shit? Oh, here, right? So they say like foo bar equals baz equals. Maybe this thing has to come first. It's single pass. Okay, wait, that's promising. So that compiled. That's really good. So now can we just start doing like more? Right, so we're like, here is like this stuff. Then yeah. This is promising. So does it behave the same way? So here we do have, this looks like the right code. Approximately. Can we do like reg list here? And then can we like even like move this push and pop in here? Like this? Like kind of slap all of this in here. And then we can go like reg list equals R1, R2, R3, or R0, R1, R2. Is that allowed? That'd be kind of hype. Can't mix positional keyword arguments. Wonder if we can do this. Unfortunate. But I guess this is kind of reasonable. If we kind of go like this. Right, so we're like, this lookup function is going to like clobber our registers. So we like push this stuff, let it do its thing, pop this stuff, and then branch to where it put the thing. That doesn't seem crazy. It doesn't seem like ideal. But what's the address here? SRAM base, it's like 2000 something. I don't know how many zeros. So px car star of this guy star at 10. Okay, so this is still working, which is really good. Now, this is not like the most reasonable, but I don't really know a better way right now. Why do the regs need to be a variable? Because it depending on the function, we might not want to push everything. You know what I mean? Like, we might not want to, if it only takes 2 arguments, we might only want to push R0 and R1. But whatever. Whatever. Yeah, okay, fuck it. This is good enough for now. So now we can start wrapping other functions. So the things that we actually wanted were enable XIP mode. Right? so that we can start interacting with the flash, even if it's like really fucking slow. So we should be able to be like, enter XIP. Like, even all of this is going to be like so duplicated, right? We're going to be doing this exact function, this exact set of shit. New ASM macro arguments register list. Maybe we can ask the idiot. Seems like something he might know. Okay. We'll ask. I have this macro. I want to add a push pop pair to a register set of registers provided as a macro argument. Is that allowed? And he's going to be like, I'll figure out. Yes, it's possible. So he's claiming to do this. I don't believe him, but I am curious. So if we do this and this, does it kind of behave the same right now? Yes. Okay. That's kind of interesting. Regs. So it's kind of like a variadic argument at the end, I guess. Which means that here we'd be like regs, and here we're like R0, R1, R2. Yeah, he's a lying piece of shit. I wonder if you can do it like this, though? Yeah. Lying piece of shit, this guy. Try regs vararg. Vararg new macro. New AS macro? AS macro. Yeah, it doesn't. Oh. Yeah. Doesn't look that pleasant, huh? Unlucky. GNU AS macro multiple registers. Ugh. GNU AS macro, like push register list. Like, surely somebody else has wanted to do this. Argument push register list. Yeah, it's crazy. Oh, whatever. Okay, fuck it. Oh, it's so frustrating. It would be so sick. I guess we can just back up everything. Fuck it. Who really cares? You know? Fuck it. I don't really want to... Yeah, just kind of fuck it. Kind of fuck it. Kind of fuck it. So it's gonna be like lookup call function. It seems like it should be possible. There's an example using variadic arguments. Oh, hell yeah. Oh yeah, how did I miss that? Wasn't I just on this page? No, this is longer than whatever the fuck I was just looking at. But that does seem like what I want, huh? Okay, we're back. We're back to trying again. Okay. So regs var arg. Like this, you're saying, right? Or var arg. Expression too complex. Push R0, R1, R2. Okay, that looks promising. But then if I put this here, he doesn't understand. Can we run macro? Because, yeah, it seems like it seems so close. You know? Like, I don't understand how this isn't right. GNU AS, like, evaluate macros and print. Is that something we can do? Ugh. I feel like this is not worth it. I feel like it's not worth it. However cool it would be, we'll go back. Fuck it. Look up. Can we do R0, R1, R2, no spaces, a single argument? I think I tried that. I think. But I'm down to kind of fucking run it back. Yeah, so at 36, too many positional arguments. I wonder if we can do something like this. Yeah. I don't think that this is the way. Yeah. I'm gonna give up. I'm gonna give up. Not worth the time. Not worth the time. Whatever. Not worth it. Yeah, fuck it. So this is like lookup call function m s now. Should be kind of the same. And then now even we kind of can do this in line. I think. Lookup call function. He's mad because it's lookup function here. It was mad about memset that one time. Oh, god damn it. you've piqued my interest. Oh, that's a good point. It's a pretty good point. Can't mix positional and keyword arguments. Okay, wait, hold on. Maybe you're onto something. Oh my god, I'm just a dumbass. Wait, that's hype. What if we do it like this? Too many. So if we put it in quotes, though, it might get processed as one. Ooh, good fucking call, dude. Yeah, that looks kind of right, huh? Good fucking call. Oh, good shit. Good shit. That was a good eye. Good eye. Okay, so now we should be able to call lookup call function of ms here, and backup r0, r1, r2. And this should behave the same way. Oops. Oh, hell yeah, dude. Print at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Print this car star 10 times. Oh, good fucking eye on the fact that we were calling the macro multiple times and I didn't notice. This is hype. This is perfect. This is exactly what I wanted. Okay. Now, maybe it makes sense to like name this as well. You could even like define memset as this. Right? You could do this. Maybe call memset. That feels pretty good. I'm kind of down with that. Right? That doesn't feel that bad. Okay, so now we can say we want to call enter xip. Call enter exp. And this is like, give me C and X. And this guy has no arguments, so our register list is empty. Oh, which it might get mad about, huh? Yeah, can we do like if here? GNU macro if or something? AS? GNU AS if. If it's blank, right? Doesn't seem crazy. If assembles the following if the operand is blank. If not blank. Maybe? Maybe like this? Unlucky. Oh, because it's not empty. True. Okay, that's promising. So maybe we do regs by default is blank. And then here we can call enter xip like this. And then I don't know if we need the backslash here. Yeah, it looks like we do. Okay. Who knows if that assembled correctly? I guess we will in a second. So looks good, right? We have our push of R0, R1, R2, pop R0, R1, R2, and then we don't have that push and pop when we do it with the other guy. That's kind of hype. I've been watching your Termi streams, cool stuff. Hey, thanks, man. That shit was fun. That was a fun little experiment. We're doing ARM assembly today. How do you find working assembly? I need to pick up proper understanding at some point. We're struggling, dude. We're definitely having a hard time, but we're getting there. I don't know how much of this is like we're struggling because we suck, and how much of this is like because like I don't know how much is the assembly versus trying to understand the Pico bootloader stuff, or both. You know? Okay, so now we should be able to do something that's like, we enter XIP mode, then we exit XIP mode. define memset other things VA args. My point was that what regs to write to push pop depends on outer context no, so we want to parameterize the preproc macro on that. I don't think so. My thought was that this is like R0 and R1, R2 are like the arguments to memset itself, not like the function state that we're trying to back up before calling. You know what I mean? Does that make sense? Like the reason that we're backing these up is because we pass these into this. We're setting up R0, R1, R2 here as like arguments to memset. You know? Okay, call memcopy. Memcopy here is M and C. And we probably could use memcopy 4, but whatever. Whatever. And then here we definitely have some registers to back up. It's R0, R1, R2. Okay. Cool. Okay, so here we can just be like, let's enter XIP. Let's then copy from the linker script tells us where CRT0 starts, I think. We have text start and text end. So we want to like load register 1 with text start, right? How do you like define extern symbol in GNU AS? Is that like a you know, because like text start isn't defined right now, but it will be defined later, right? Right? Like, I kind of want to do something like this, but I don't know if it'll let me, you know? Right? Because here's like, oh, here he's just like, what the fuck are you talking about? I guess we could look at what they do in their boot too. Right? Surely they're using, or maybe they're CRT0. Oh, here. Ah. So they call .word with that function, and they put it somewhere. I see. So here we can be like text start is word of text start, and text end is this. And then I guess we have to do, oopsies, text end here. I guess we load R2 with text end, and then we do like sub R2, R1 or something. What's like the sub command? Where are fucking like ASM instructions? They're gonna be like somewhere by where it says Cortex M0 here. Here, there's gotta be an instruction table here. So subtract destination N and M, so it's probably like sub R2, R2, R1 or something. Seems kind of reasonable. That compiles. That's kind of hype. So can we breakpoint here and just kind of see what fucking happens? Continue. Info registers. Oh, interesting. Because text start is we've got the virtual memory address here, but we want like the physical memory address, right? So that we know where to copy from. So how do they handle that? Right, like they have RAM text source. Can we look at their like LD scripts here? Provide, so they can do this type of shit. Can we like store the loaded memory address of things? Interesting. New linker script, like store, like save LMA as variable or something, like. This feels like a question for the idiot. In a linker script, can I can stash the start end of a segment as segments VMA virtual memory address by doing something like this. Can I store the address, the LMA instead? Question mark. Let's see. Load adder? I mean, that's maybe. I mean, we might as well try it. Who knows if he's a lying piece of shit? But he might not be. He might not be. Undefined section. Oh, so this is like text plus size of text. He kind of wants to do something like this. That's promising. That's definitely promising. Info registers. Okay, so this is really promising as well. So register 1 has the flash address of this guy. And can we even disassemble maybe 8 bytes here and see if it looks like our code? That'd be kind of hype. This does look like our CRT0. So this means that XIP mode has been successfully enabled, and our memcopy should do the right thing now. I think. So if we look at the stuff that is in SRAM base now, 2000000. Ooh! That's so sick. So not only is that stuff disassembled correctly now, but also it has noticed that this is in the function start. So if we do like disassemble start here, it looks correct. But if we were to do monitor reset init and disassemble start now, before we've done the copy, oh, interesting. I guess maybe the RAM is left over. If I unplug and replug this thing to like really force it to like lose its fucking mind, clear all RAM, then I do this, disassemble start. So this is garbage, hype, continue to a breakpoint. I think that we haven't run it yet. Now, it looks pretty fucking good. Woo-wee! So we now have CRT0 is totally reasonable. That's so fucking hype. And now we can disable XIP mode. So we call memcopy, we call exit xip, and now instead of just going back and doing that shit again, we should set the stack pointer to the end of SRAM. We can probably leave the stack pointer as is for now though, who fucking cares? And we can just branch to start. We might have to load this into a register. Maybe. Branch. B label. Yeah, so now that this thing's in the right spot, we can just call it like this, I think. We don't need memset anymore, and we don't need a breakpoint here anymore. And we don't need this label. Maybe. Start. Relocation truncated to fit. Start to find a text section. Oh, so we have to do, because it's too far, we might have to put it in a register first. You know, something like this. How do I branch to, oh, BX maybe? Undefined reference to R0? Do I really have to, am I fucking stupid? Oh, B. Okay, that's not good. But we're getting close. Can we breakpoint here? Okay, info registers. So R0 has the address of 2000, and then the question is, why are we not going there? So here, our program counter is right at this branch. If we jump here, oh, we're in start. Okay, well, that's a good sign, I think. He did go here. But now this doesn't seem to be working correctly, which is kind of interesting. What happens if we just take this breakpoint out and just, like, fucking let our boys fly? We're just like, fucking run it, bitch. Yeah, we've ended up somewhere very bad. Which is confusing to me. Because things were looking so good. Okay. So this is interesting. This breakpoint should be here. What the fuck is going on? Okay, so we've hit a breakpoint right before the branch to CRT0, right? We have the address of this guy. Disassemble this plus 8. Right? So this does have breakpoint in here at address 2000. That's hype. That's cool. Everybody's happy. Right? Everyone's happy. So then, why the fuck can't I jump there then? What the fuck is going on with this BXR0? I wonder if it's relative. They might always be relative. That wouldn't, like, heavily surprise me. ARM branch exchange. Branch to an address. It has encodings in the following instruction sets. Okay, so this is ARM v8, which is not helpful. ARM v6 bx. I mean, 7's pretty close. 7 and 6, I think, are basically the same. 8 is, like, pretty fucking different. Can we do, like, ARM v6 reference manual? Is that helpful? I don't know if M is right, but fuck it. BX. Okay. Can we fucking... Here we go. Okay. Branch exchange causes branch to an address and instruction set specified by register. An attempt to change execution state, blah, blah, blah. Branch target address. So it doesn't say anything about being relative. Right? Like, BL is also not relative, but it needs an immediate value. Okay, sure. Can we do like branch? Is there like relative? Arm branch relative. Just to, like, to clear my mind a little bit. B is a relative branch. Okay, so what do they say about B? Are these sorted by, yeah, B. So this is target address. So this doesn't say anything about it being relative. Sets on encoding to that offset. Oh, offset. Okay. That said offset specifically. Offset here as well. BLX. Or BX is the instruction we're calling. Oh, and instruction set. That's a good point. Is the lowest bit set so that it switches to thumb state? Or out of thumb state? It should be in thumb state. Ah, I didn't realize. Good fucking eye there. So... instruction set selection bit. So if M is equal to 15, then unpredictable. So RM encoding all versions of the thumb instruction set and instruction set selection bit. Okay. So is it the lowest bit? Which means that maybe I want to do something like this. Is that really how you're supposed to do this? So now it says 2001. And because then we should be able to go like step instruction. That's promising. Good fucking call there. So if I do start plus 0, let's take away this breakpoint. What was it? Fuck. GB, compile in GB. So here we hit continue, and it's fucking broken. And here we do +1, and then that works. That's super fucking interesting. So I have to know that that thing is thumb, and it doesn't do that for me. That's confusing. That's interesting. I don't know how I mean, yeah, that's quite surprising. Quite surprising, but I guess, like, cool. So I'm hit C now and then hit break here. We're in our fucking loop. Let's fucking go! That's pretty hype. Pretty hype. Labels seem relative, registers seem absolute. Yeah, that's kind of what I was grokking from this as well. Cool. Cool. So what? We're 3 hours in, and what did we accomplish? Basically all of this boot2 file. So we figured out how to look up functions in bootrom 0, specifically the functions to enter XIP mode, do a memcopy to take that stuff out, and then exit XIP mode. Then jump to CRT 0, which means that we also managed to get CRT 0 into our executable, right? So that was also today. We added CRT 0.s, which is now part of our linker script. Linker script now sets the stuff in text to text, and we jumped there, and that's pretty hype. That's pretty fucking sick. I think that's pretty good progress for today. I would have been happy with more progress, but now that I know what we had to do here, I feel pretty good about what we accomplished today. That was pretty sick. So I guess the next steps would be to get from here to C. I assume that's not very hard, right? In fact, it might be no work. I don't really see why we couldn't just call main right now. I guess we might want to set up like interrupt vectors and shit, which we don't have, but maybe we start by not doing that. But yeah, looking pretty good. Need to memset BSS. True. I guess yeah, it depends on like what our expectations are. If we want to go into Zig code too, we'll have to figure out what like the Zig runtime expectations are. But pretty exciting stuff. Pretty happy with that. Thanks for watching, guys. If you is the goal here to get to use libc? I don't know if I want to care. I don't know if I care about libc. I might just care about like a no std environment. We'll see. But yeah, thanks for watching, guys. If you like what we saw, we stream most days at around 12:50 Pacific time to 4 o'clock Pacific time. It is 3:45 now, so anywhere between 3 hours and 15 minutes ago to 15 minutes from now is when you should expect to see us live. Right now we're working on this Raspberry Pi Pico stuff, but there's a lot of stuff in the backlog. Other projects if you want to check them out. There's like, terminal emulator, operating system, Google Maps, video games. Like we're variety streamers around here, but variety within the context of writing code. So that's all on the YouTube. Sometimes we stream, but the content that we're streaming, I don't really feel like is very titleable and thumbnailable. So like if we're doing refactoring, unit testing, reading about stuff, it's kind of like, I worry a little bit about posting everything to YouTube because the YouTube algorithm is our friend and we want to be nice to it. So the rest of the stuff we call happy hour. And if you want access to that stuff, you either have to catch it live, or the happy hour VODs are archived on Patreon or under YouTube members or on Twitch at the appropriate lengths or whatever. So if you want access to those, because you can't catch them live, you got to support on whatever platform, please consider supporting because this content will end someday, right? But that day is marked by a dollar amount in my bank account. So every dollar I make doing this extends that day out a little bit further. But if not, if you don't want to, no worries at all. Otherwise, I think that's it. YouTube, peace out, and Twitch is fun someone to raid.